Okay, this is certainly something new for a lot of students. You're given an online document, and we're in section 3 now. So certainly you can scroll to that if you want. Let me just close the sidebar. Okay, so I'm going to just click here. This is a section I'm looking at the table of contents, and it brings you right there. What have we done so far? We've done a simple review of material that you actually did learn in prior courses. Now, whether you learned them at Essex College or another school, you learned how to solve a general linear equation. So we give you certainly a lecture on this, but a lot of times for lectures, students have a tough time following the lecture. We do write it up for you though, which should make it a little bit easier in the note-taking department. I also want to encourage students that are having trouble following what's being done in lectures, that there's little tiny videos on the side that we would encourage you to watch if they're helpful. If they're not helpful though, we're not going to encourage you to watch that. We want to encourage you to do things that are helpful. I'm going to say attending lecture should be helpful. Also attending the examples that we're going to do today also should be helpful. I also want to claim though, for some students, things may go too fast. If they go too fast, all I can encourage you to do, try to listen, try to follow. But you can always come back later, and these lectures will be published online, and you'll be able to watch them then, and we'll go through that later. But right now, I want to claim what's been done. We went through a simple review, and certainly we covered this material over here. And again, the point of reviewing this material is, I'm not going to say that you understand everything that's being said, but you're being introduced to things that you've seen in the past. What do we need to do though? We need to get to examples. So what I'm going to do now is I'm going to do the examples. The general structure of the example is going to be a question, and in the blue area will be an answer. I'm going to encourage you to take notes though. However, some students have a tough time taking notes. So that's where the listening department comes in. Listen, you can always come back and watch these later. For the students that want to watch little spot videos on the side, there'll be a little video that would go through this question on an individual basis. Right now, what are we going to do? We're going to go through the examples. So I'm going to switch to the whiteboard. And this is going to be a general structure of what we're going to be doing. I'll go to the whiteboard, right? I'll do every example. And as I'm doing that, I want to claim the way I'm going to do that, I'm going to go question by question. Again, for some students, it goes too quickly. For some students, it goes too slowly. We're encouraging you to learn at your pace though, right? And that's what's interesting. You can learn at your pace, including if you say, oh, geez, I'll just listen and I'll do something else while I'm listening. That's fine too. We're trying to get you to learn the material though. So what I want to do is I want to just pull this question onto the side. And this is going to be the general structure. What I'm going to be doing, I'm going to be looking at a question. I'm going to read it to you, of course. And I would encourage you also to read. What happens to a lot of students, they don't read, and then they start doing things they have not been asked to do. So my claim over here says, is 5 a solution to this equation over here? Well, let me write down the equation. The equation 6y minus 5 equals 5y. And their question, is y equal 5 a solution to that equation? Well, what we want you to do is verify that it's either true or not true. So let's write this down. So what I would do is I'd plug it in. I believe y is 5. And wherever I see y, I'm going to put the 5 down. And let's do the arithmetic. Excuse me. 6 times 5 is 30. 5 times 5 is 25. I'm just simplifying. 30 minus 5 is 25. And 25 does, in fact, equal 25. So the answer to this thing is yes, it's a solution to the equation. What are you going to do? Check your answer against the key. I do want to encourage you, though, to put the work down. This is the work. All right, let's go to the next problem, which would be number 2. All right, now, I'm going to claim for some students, these require no work, but I still want to put the work down for you. All right, so I'll put number 2 on the side. We'll do number 3 later. So number 2 says SOB and CHECK. All right, let me copy the question. Whoops, let's go back to black ink. The work for this problem is both sides are simple. The variable is on one side. I want to get the constant on the other. And the way I'm going to do that is by subtracting the constant 6 from both sides. And if you did that, what do you get? Z equals, well, 11 minus 6 is going to be 5, right? Then what do you do? Well, you divide both sides by the variable's numerical coefficient, which would be 1. There'd be essentially no change in the problem. Now, I realize some students are going to say, I don't need to write down that I'm subtracting 6 from both sides. And I'm not saying you do. However, it's nice to put some work down. So if you make a mistake, at least people know where you made the mistake if you write work down. All right, so I put my work down and I want to see if the answer is correct. What this every year? C equals 5, C equals 5. Now, if you're on the exam, you know the answer K. So what I would suggest you do is just look at the original problem. And the original problem's right over here and see if that makes sense. And again, this is what I would call a check. What do I believe Z is? 5. And what's 5 plus 6? 11. And 11 does equal 11. So it works out beautifully. Let's go to problem number 2. I'm sorry, number 3. We just did number 2. And I'll pull it to the side. Okay. There's many ways to do it. I'm not suggesting there's only one way to do a problem. The way I'm looking at this though now is I'm looking to get the variable term on one side, it is, and I'm looking to get the constant on the other side, and that's not the case. So what I would do, I would recommend that you subtract 1/3 from both sides. And if you did that, what would you get? You would get x equals, well, 2/3 minus 1/3 is 1/3. So I'm going to say, well, it's done. If you want to, you can divide both sides by the variable's numerical coefficient, which is 1, but it's not going to change the outcome. So I'm going to say that's the answer. Now, what I would claim to do over here is look at the K where they say x is 1/3, but I also want to check it. Because this is an exam question, I want to see if it's right. What do? I plug it in. 1/3, that's what I believe x is, plus 1/3, in fact, does equal 2/3. It works beautifully. All right, let's go to number 4. I'm going to pull that one on the side too. Goes down a little bit. Okay, so certainly I'm not going to claim you can't subtract 5, 6 from both sides. You can do that, and you would get the variable term on one side. What I'm going to suggest instead, though, is to get the LCD in the problem. And let me write that down for you. So the LCD. Now, I'm hoping when you're looking at this, you want to know the LCD between 6, 12, and 4. The LCD is also known as the least common multiple of those numbers. And if you were to write down the multiples of 6, the multiples of 6 would be 6. The next multiple would be 12. The next multiple would be 18. Unfortunately, this goes on forever. And what are the multiples of 12? 12, 24, 36, and that goes on forever. The multiples of 4 are 4, 8, 12, and that goes on forever. What's the least common denominator? It's actually the LCM of those things. Well, if you look at it, I hope you can agree that 12 is the least common multiple, all right? So I'm going to write that down. The LCD is 12. What do we recommend you do? Multiply both sides by the number 12. All right, let's do one at a time, and I'll write this on the side for you. 12, not on the side, but on the same piece of paper. 5/6. This is the distributive property of multiplication. 12 times n over 12 equals minus 1/4 times 12. Let's go through it one step at a time. 6 goes into 6 once. It goes into 12 2 times. All right, to the next one. 12 goes into 12 once. Well, that's not so bad. 4 goes into 4 once. It goes into 12 3 times. Let me go through the work. First term, 2 times 5 is 10, plus second term is 1 times n, which is n, equals, well, now I got minus 1 times 3, which is minus 3. What do I recommend you do now? Well, subtract 10, the constant, from both sides. And what do you get? N equals minus 13. I'm going to put a box on that, indicating I'm done with the problem. I know what n is. I do want to check it against the k, but I want to just check it in the original problem. And this is where some student says, I don't want to do that. And that's fine. I'm not saying you have to. I'm going to put the check down. And this is going to be 5/6. And I believe n is minus 13. So it's going to be plus minus 13 twelfths equals minus 1/4. Well, on the left side, the LCD is 12. What times 6 gives you 12? 2. So 2 times 5 is 10. And that's 10 minus 13 now. There's not much I can do with the right side. What's 10 minus 13? Minus 3/12. Does minus 3/12 reduce? Of course it does, to minus 1/4. So it checks out beautifully. All right. So I'm going to go to problem number 5 now. And number 5 is, SOB and CHECK. My goal here is to look at the problem and get the LCD again. All right. So what's the LCD then? There's only one denominator. So the LCD is 5. And what are you going to do now? You're going to multiply both sides of the equation. Let me write this down for you. You're going to multiply both sides of the equation by the number 5. Relatively simple. On the left side, the 5s would cancel and you get x. On the right side, you get minus 15. Check it with the key, and the key says minus 15 as well. I do want to point out on exams, though, you don't have a key. So I want to put this down, the check. What do you get? I believe, and I check it in the original, minus 15 over 5, and that in fact does equal minus 3. And I realize some students will argue, I can do that without putting any work down, and I'm not saying you can't. I'm just saying it's a good idea to put work down. All right, this worked out nicely. Let's go to problem number 6. The next page. I'm going to pull that aside for you. And we'll go through it. And what would I do over here? I'm looking at the problem. And what I would recommend you do is, just get the variable term on one side. And it's unfortunately on two different sides. The way I would accomplish that is I would subtract 3b from both sides. All right, what would you get there? Well, on the left side, you would get minus 3. On the right side, you get 2b. Now, what would I recommend you do? Divide both sides by the variable's numerical coefficient, which is 2. And what would that give you? Minus 3 over 2 equals b. And that's my answer. I want to look at the key, and I'm pointing out in the key they have that. I still want to check it. And how do I check it? I want to go back to the original problem. That's 3. I believe b is minus 3/2. Minus 3 is equal to 5. And again, I believe b is minus 3 over 2. Again, I want to emphasize we went back to the original. What do you get over here? Minus 9/2 minus 3 equals minus 15/2. Well, the left side common denominator is 2. That'd be minus 9. I'd have to do, because I'm going to count them, that has to be minus 6 now, right? Because minus 6 divided by 2 is minus 3. And again, I believe that's minus 15/2. What's minus 9 minus 6? Minus 15. Of course it's true. All right, this checks out beautifully. I realize some students may argue they don't want to check, and we're not going to force you to check. It's good to know that you can check, though, and most problems are simple to check. Let's go to problem number 7 now. And I'll pull it on the side. Oops, sorry about that. Remember, in the blue area, I have the answer there. Right? Somebody else, I'll just trust you on it. I don't think that's a good idea. All right. So I only see one fraction. I'm going to write the LCD down. What's the LCD? The LCD is 6. What am I going to do, though? I'm going to multiply both sides by the LCD. All right, I'm going to go through that one step at a time. The left side, it's the distributive property multiplication. That's 6 gets distributed across 2 terms. First term minus 6 times the second term. And then 6 times 6 on the other side, I'll write it down for you. Really not an issue. I think I can do that. And we'll do one thing at a time. What's 6 times 6? 36. let's see, 6 times 5t is minus 30t. And what's nice about that first term, the 6's cancel. So what are you left off with? 1 times 1, which is 1. All right, now what am I going to do? Well, I want to get the variable term on one side and the constant term on the other. So I'm going to subtract 1 from both sides. And what do you get? You get minus 30t equals 35. Then what are you going to do? Well, you're going to divide both sides by the variable's numerical coefficient. The variable in this problem is t. And what would you get there? You would get t equals, well, it's really not right to have a negative number in the denominator. So we either put it on the same line as the fraction or on the top number. So I'm going to say I could also reduce it. And 5 goes into 35, 7, and it goes into 36 times. So I'm going to claim this is my answer. And I'm going to check it against my little blue area. And that's what it says. Now, what I want to do is I want to see if that's true. All right. So what I'm going to put down, put the check down. So it's going to be 1/6. I'm checking the original problem, minus 5t, and I believe t is minus 7/6 equals 6. All right, let's go through it. This is 1/6 plus 35/6 equals 6. Well, what's 1 plus 35? It's 36 over 6, and that, of course, equals 6. So it does check out. All right, let's go to number 8. And let me pull it on the side. Just give me 1 second. Just give me a second to do that. And again, for the students finding this going way too fast for them, you can watch little spot videos or come back later in the week and just simply watch this. All right. So let me see if I can do it. So what's the first step? The first step is to simplify the side now because there's something that can be done. So I'm write that down for you. So it's 3y plus, I'm going to remove the grouping symbol by using the distributive property multiplication. So the 3 distributes across the y and the 1. Okay, I'm getting combined like terms. You get 6y plus 3 equals 27. So I'm done with the simplification. Now what I'm going to do is, variable on one side it is, but I want to get the constant on the other. So I'm going to subtract 3 from both sides. And what do you get? You get 6y is equal to 24. All right, let's keep going. Next thing I'm going to do is divide both sides by the variable's numerical coefficient. And what would you end up with? Y equals 4. Again, my claim over here, check it with the k. That looks good. We agree. But also check with the original problem. And what do I believe? I believe y is 4. So the original problem says 3 times y plus 3 times y plus 1. Well, I believe y is 4. 27. Let's see if this is true. Well, 3 times 4 is 12. And 3 times, well, 4 plus 1 is 5, right? 12. 3 times 5 is 15. And lo and behold, 12 plus 15 is in fact 27. All right, let's go to number 9. And number 9, for some students, they look at this and say it's too much work. We want to encourage that work. Now, what's the work we have up here? Simplify each side. So what do you get? You get 8 minus. Now, here's where some students trip up. I want to point out, it does say subtract 5 times that. Now, what I'm going to do is say minus 5 times this and minus 5 times that. Let's see what we get. So you get minus 20. And let's see, minus 5 times minus 5 is plus 25. And that's an x. Let's go to the right side. Distributive property, 3 times 4 is 12. And 3 times minus x is minus 3x, minus 8x. Mistakes happen. And when they do happen, at least try to determine why a mistake happened. All right. I'm still simplifying the side. You get minus 12 plus 25x equals 12 minus 11x. Well, I want to concentrate on getting the x on one side. Now it's on 2 different sides. And the way I would accomplish that is by adding 11x to both sides. In time, you'll become much faster, but right now, let's take it slow. Minus 12 plus 36x equals 12. All right. So what are you going to do now? Well, I want to get the constant on the other side, and I'm going to do that by adding 12 to both sides. Now, it happens to some students, all the writing, they make mistakes. You're going to know that in the end. All right. So what do I do now? I divide both sides by the variable's numerical coefficient. And what do you get? Well, you get something pretty simple. You get x, and immediately notice thing is reducible by a factor of 12. So 12 goes into 24 twice, and it goes into 36 3 times. All right. So what do I want you to do? I want you to look at this and look at this and make sure in agreement. I would also recommend, but again, for some students, this is not a good idea. I'm going to recommend you check it though, if you can. If this takes you a day to do though, this is not a good idea. Let's see. If x is 2/3, what's 5 times 2/3? 10/3. That's work. I understand that. And now we got 4 minus 2/3 minus, well, let me just push this guy over here. Whoops, sorry about that. Let me go back. And what's 8 times 2/3? 16/3. Now, I want to point out the reason this is so difficult for students is the arithmetic skills. If your arithmetic skills are really bad, this is probably going to be very unproductive, including if you're using a calculator, still unproductive. What do you have here? 8 minus 5 and 4 minus 10/3. Well, that would be 12/3 because that's what 4 is, minus 10/3, which is 2/3. And it's going to be 3. Let's see, you get 12 because 12/3 is 4. So 12/3 minus 2/3 is 10/3 minus 16/3. All right, let me keep going. This could be 8 minus 10/3. I'm checking. I know it's a lot of work. Now, it's something you do something kind of crazy here. Some people just say 10, but I can say 30/3. It is 10 minus 16/3. Wow, a lot of work. What's 8? It's 24/3. What's 24/3 minus 10/3? It's 14/3. What's 30/3 minus 16/3? 14/3. It worked out beautifully. It does check. Again, for students that have tough time with arithmetic, this is not recommended. All right, what's recommended? Well, get your answer, check it with the answer key. If you're doing WebAssign will say you're right or wrong. All right, I think check is an important skill though. All right, let's go to number 10 now. Let's take a look. All right, you're gonna pull it on the side. And I'm going to talk you through it. The first thing I would recommend you do is to remove the grouping symbols. Now, of course, on the right side, let's go back to black ink. On the right side, it's super easy. It's 6 times x, which is 6x, plus 6 times 5, which is 30. There's not much I can do about that. That's as simple as it gets. On the right side, though, an error a lot of students do is they do this. They do 5 plus 3 and they say it's 8. You're not following the order of operations. The order of operations, you have to take care of the grouping symbols first. Let's do that. So 5 plus 3. Inside the grouping symbol, I see something. What do I see? Another grouping symbol. So it's actually 2 times 2x and then 2 times minus 3. Let's write that down for you. 2 times 2x is 4x. 2 times minus 3 is minus 6. Now, some of the arguments students give you say it just takes too much time, that I want to do a bunch of steps at one time. And we're not going to stop you. We're just going to say, if you're making errors, we want to stop you from making errors, certainly. Let's keep going. Now, I'm going to say 4x, and 1 minus 6 is minus 5. All right, let's keep going. 5. Well, now I'm going to use the distributive property of multiplication to remove the grouping symbol. That's 12x minus 15. Yeah, this is a lot of work. What do you get over here? Well, you can get 12x minus 10 equals 6x plus 30. All right. I'm going to claim that I've done the simplification process. Now I want to get the x's onto one side by an addition or subtraction. And I'm going to subtract 6x from both sides. All right. One step at a time. What do you get? 6x minus 10 is equal to 30. All right, let's keep going. What I'm going to do now, constantly on the side by adding 10. Sorry about that. Just let me get rid of that. Whoops, I didn't mean to do that. Let me go backwards. I'm confused there. I am going to add, write that down for you, 10 to both sides. And what do you get? You get 6x is equal to 40. Then what I'm going to do, divide both sides by 6. Relatively simple. Let me put that down for you. And what do you get? You get x, and 40 divided by 6 is 20/3. I want to point out that some students want to write down, a decimal, which I'm going to try to discourage that. But some students want to write a mixed number down. And the reason for that, their teachers told them, particularly when you're in grade school, they told you that you shouldn't write that. It's an improper fraction. But you can do it. I'm just going to say it looks peculiar to me, especially in algebra. That would be 6 2/3. All right. I wouldn't grade that as being a wrong answer, by the way. But the bottom line is we prefer this answer in algebra. Let's see if it's right, though. And so it's a lot of work. Okay. If you want, I'm not going to do it for you, though. You could check it here. You could check it. How do you check it? You plug in what you believe the answer is, which is 20/3. Right. I don't recommend it for a large number of students, though, because the amount of work involved in it is just overwhelming. All right. So let's take a look. And that was number 10. Let's go to number 11 now. I'm going to pull on the side. Just give me a second to do so. All right. And it looks nightmarish. It does. And my claim is if you can take one step at a time, that's going to bode well. I'm going to do the right side. 3. I'm working inside the grouping symbol. I know it seems difficult. What do I see in that grouping symbol? I see this. I see 2 times these two terms. 2 times 4 is 8. Whoops, I didn't mean to do that. 2 times 4 is 8. And 2 times minus x minus 2x minus 5. I'm going to keep working with this side. And what do I get? 8 minus 5 is 3. 3 minus 2x. Now I'm going to remove the grouping symbol. 3 times 3 is 9 minus 6x. Do mistakes happen? Of course they do. We'll know we made a mistake when we look at the answer in the end. Let's put the other side down. I see 5, a long grouping symbol, x plus, well, I'm going to remove this guy. 2 times 3, 2 times minus x. Let's write that down. I'm still working on it. And let's see, you get 6 minus x. What do you get there? Well, 5 times 6 is 30. And let's see, 5 times minus x minus 5x. What am I going to do now? Well, I'm going to add 6x to both sides. All right, let me do that. And what do you get? You get 30 plus x is equal to 9. Now what I'm going to do, subtract 30 from both sides. And what do you get? X equals minus 21. My recommendation, look at the answer key and see if you can agree with it. And that's good if you can. All right. Okay, next up, which is going to be number, let's take a look. We'll go backwards here, right? Not backwards. I don't want to go backwards. I want to go number 12, right? Wow, 12 looks tough. All right, I'm going to pull on the side. Oops, I don't think I did that. And let me look at it. All right, so what I would do first, I recommend as you do as well, is write the LCD down. So what do I see? I see 2 and 8. The LCD is 8. My recommendation to you is to multiply both sides by 8. I'm going to write that down for you. And that is like multiplying the 8 across the 2 terms on the left side. I'll write that down for you. There's 2 terms there. The right side is relatively simple to do. And why is that? Well, the 8's cancel, and we left off with 3. All right, now we do this over here. I'm going to go 8 into 8 goes in 1 time. That's not bad. 2 goes into 2 once, goes into 8 4 times. Got to remove those grouping symbols. 4 times 5 is 20. Minus, well, 4 times minus 2x minus 8x. Remember, when I cross something out, the number 1, and 1 times x is x, and 1 times minus 3 is minus 3. Let's keep going. I'm looking at it. 20 minus 3 is 17. Minus 8x plus x is minus 7x equals 3. What I recommend you do now, it might seem difficult to you, but I'm going to subtract 17 from both sides. What do you have here? Minus 7x. 3 minus 17 is minus 14. What I recommend you do now, divide both sides by the variable's numerical coefficient. And what do you get? X equals 2. Let's check our answer. And what it said, X is 2. That's good news. All right, let's take a look at number 13. Number 13 is what's known as a literal equation. All right, how many letters are in it? Well, there's a Y in it, there's an M in it, an X in it, and a B in it. There's 4 letters. Now, certainly if they say solve for Y, I'm done because I know what Y is. Y is MX plus B. Here's what they said though. They said solve for X. So what I'm going to do over here, let me write the equation again. A lot of students get tripped up on these, but I want to keep that variable term on one side, which is the X. I'm going to subtract B from both sides. What would you get? I would get Y minus B equals MX. All right, now what do? Divide both sides by the variable's coefficient. Now, in the past, I said numerical coefficient, but now the coefficient is not numerical, it's a letter. And what would you get over there? You would get Y minus B over M is equal to X. Put a box on it, and I'll check it. What they say, X equals Y minus B over M. Now, some people say, oh, that's in a different order. Equations are reflective. Any order you put it down is fine. All right. So let's take a look. I think we finished all the problems. I think so. Yeah, we finished them all. All right. So what do you do now? Someone said, I don't know what to do now. Well, I would go back and, certainly reread the notes. Make sure you understand what was presented in lecture. I would redo the examples we just did. And then after you feel comfortable with the material, do the supplemental problem set, which can be in the very next page. Do the supplemental problem set. After you get through the supplemental problem set, if you have no questions, you're ready to move on to WebAssign. However, if you have questions about the supplemental problem set, I will post a video of me doing those supplemental problems at the whiteboard if you need it. Okay, I'll publish it. Thank you.